Okay, my friends, get ready, because I'm going to tell you right now, we created magnetic monopoles, never done before. We created muons on a tabletop, never done before. Electron neutrinos on a tabletop, never done before. Muon neutrinos and sterile neutrinos on a tabletop, never done before. I'm going to show the evidence, and I'm going to show you that we exceed CERN and Fermilab by an order of magnitude that's unbelievable. They're working with gigantic particles and spreading debris everywhere. We're using focused light to do our research. That's what they've been searching for long ago. Okay, this is from Fermilab. Now they have seen two particles attached together, a white one, which is the electron neutrino, and a black one, which is the muon neutrino. And they claim they're neutral, they don't have any charges and so forth. Now, you see this Cherenkov radiation from a muon produced by a muon neutrino event yields a well-defined circular ring in the photomultiplier detector bank. Now, the electron neutrino, the white one though, produces electron showers and gives you a big cone of electron showers. Alright, so there's the two, and then this one goes by itself. This one makes showers. Let's see if I can show you that. Okay, don't forget, these are the neutrinos we're looking for, the black and the glowy one. And here's what we found. But we found them in light. Alright, this is light, pulsed laser. And these are photons. This is the same particle. This just shows its energetic values. But you see, this is what they're made of. And they say, yes, Fermilab agrees, this is the smallest particles there are. A fixed and a point particle. Exactly what I say. A fixed never changes. Point, get glowy, bigger or smaller. And the glowy one turns into the electron showers, just as what I showed you a second ago. These actually split too, which is fission and fusion. So we had the muon, the black one, and the electron neutrino together. The muon goes on its way, and that creates a shower. Well, there it is. There it is. The black one goes on its own way. And the white one goes through the venturi, is the only one allowed, and it's so explosive you can't even see the venturi. All the venturi is a very curved surface to force all of the fields to concuss together, being pulsed by the pulsation of the laser. And the black fixed particles, they never get small. So they're banging like this. And that's what's coming out of here is all the electrons in showers. That's what they show. That's it. And I can show you all three types of neutrinos that they claim exist, which is the black ball, the black and the white ball, muon, electron neutrino, and a tau neutrino is this. A tau is that. It's two black balls and a white in the middle. And it's heavier than the other because the black has all the weight. So it counts for everything. And every single thing there is made of these two particles. There is nothing that isn't made of those two particles. And here is electron flood theory right there. Alright, and what this means is there is nothing but dipoles. So that black and white should have been there forever together. But when we put it through the venturi, the black says, I can't get through there. I said, well, sorry, I gotta go. And it goes squirting through. So what we always considered was an electron, because we never saw the black before. No, nobody's ever seen it. The electron is the black and the white together. But the white one burns like hell. The black is it's a heavy carrier. It's almost like a car holding a gas bomb. You could think of it that way. It's like it's the two of them together. One of them can run over a person and kill them. The gas, you could throw it on them and burn them, but you can't kill them by throwing the gas on them, hitting them. This, that you could kill somebody with the muon banging into them. The gas, or the electron, would burn them. And I can show this for a fact using the nuclear bomb blast. The first thing that hits is the electrons. The house just vaporizes. And the next thing, a second later, is the house goes flying like crazy because the bomb hits the big black particle. So we have two types of energy. We have pushy energy, which is this mass, and then we have Bernie energy, which is electrons. And the electrons, apparently, the only thing I can think of is there's so many electrons which have almost no mass whatsoever, are invading everybody else's electron space, that they're just vaporizing everything because they can't absorb that many electrons that fast. Okay, you ready for some proof? This is an atomic explosion. This is an atomic bomb. Believe it or not, it's an atomic bomb. Now, what is this? Atom Central is the station, the channel, and we're going to see an atomic bomb go off. Here's what's going to happen. This is an atomic bomb. It's sitting on a tarmac. They explode it. Well, what do they do with an atomic bomb? They force everything in, and then everything comes out. Well, what comes out? The first thing that comes out is the white particles, which always surround the black. I just showed you that in outer space. That's what happens. The white surrounds the black. So the white goes first. And the white, as I showed you, has no real mass to it, but it burns like hell. The black has a ton of mass and no burn. So what would you expect? The house would just burn up, and then the house would get pushed away. Guess what happens? Precisely that. Here we go. So this is way slowed down. So here's going to happen. Boom! What happens there? The house burns up. It didn't go anywhere. It was just burning. That's the white particles hit. What's going to happen next? The black ones are going to come next and take the house down. Boom! You see that? It's exactly what I showed you. The white ones, which are the burny ones, they have no mass, they burn the house. The black ones, which have a mass but no burn, knock the house over. Now, what happens is the black is still quite a bit of it back in the beginning, but all the whites are gone. They're history. They're toast. Now, it wants to pull them back in, so everything sort of turns around and comes back. Watch what happens. It's precisely that. Here it goes out. Watch what happens. It's going to sort of turn around. See it turn around? Coming back. Exactly what electron flood theory predicts. Okay, you see this right here? This is literally a black hole in space. I showed you, or will show you, that we can separate the black from the white. These are the white, this is the black. That's what it is. These are charged particles they put into a vacuum chamber in zero gravity. You can't do this research where there's gravity. All of those whites would be flat like a pancake. Out there, they can go where they want. They push the black into the center, surrounded by the white. That's a true black hole. Now, the crazy thing here is, I'm kind of upset with Don Lincoln at Fermilab because it's been 6-7 years. I've been trying to show him this. This goes back to 2015 is when they did this. And I had worked with the Russians. I didn't really work with them. They got a hold of me because I did the research on sinkholes, and they were having a hell of a problem, and they still are. Everybody is, with sinkholes because of the tundra collapsing. We're having the same problems. Everybody is. And anyway, we talked about that. So I was communicating to them about this black hole that they created in space, because they didn't know. See, says during the experiment we contacted the Earth guys who couldn't believe it either. One of the guys from Max Planck locked himself in his office for 3 weeks because he freaked out. They still don't know what to make of it. So I'm contacting them, telling them, you guys created a black hole. These are the neutrinos, and this is the black side of the neutrino. We have found these particles. So I copied Don Lincoln in on this. So I got the Russians and Don Lincoln in on the same correspondence. Well, he makes a big joke out of it, like, oh, that's nothing. Well, so then I said to him, I said, Don, we found the particles you want. I show you the white and the black. Here's the same particles you found. And he said, no, you can't see those. Nobody can see those. And well, and we went back and forth quite a bit. And because he asked, he says, ask questions. I want you to ask questions. I'll tell you the answers. I asked him, but by the time I was done, he had no answers. All he could say was, don't ever contact me again. And I'm serious. That's how it ended. Now, that's why I'm upset. I'm trying to be nice. But this is not correct. He's a government employee. I pay taxes. He's spending billions of our dollars and refusing, literally refusing, to engage in science. That's what upsets me. Now, I'm as qualified as anybody on walking the face of the planet to talk about this. This was the work I did right after getting out of the Army, working on Nike Hercules missiles 50 years ago. There's two types of energy. There's dipole-dipole interactions, induced dipoles, polar molecules, nonpolar molecules. That was a little tricky to figure why someone would do that. But anyway, I got that figured out. Transfer of energy. This is the key right here. The transfer of energy is from light to atomic vapor. Light is the black and the white particle, and it's atomic vapor. That's all it is. Coming from the sun, that's all it is, atomic vapor. Now, I have a very, very good understanding of this. Like I say, I did this as deep as anybody walking around, and then the rest of my life, realizing that this was all dipoles and nobody would talk to me about it, I went into electronics, and which is basically the same thing, because at that time we were developing all kinds of new things. You know, here's more light energy and, you know, photons and all this, but I realized this is all nonsense. It was all nonsense. So anyway, I went into electronics, and I've kept my finger on the pulse ever since. Now, these neutrinos, I've known about this dipole nature of light, and the neutrino is a dipole particle. Okay, I just want to make a couple of quick statements before we get started. I communicated with Don Lincoln, who wrote this article right here about these two particles, a fixed and a point particle. I said, Don, we have found these particles. We photoed them. I know what they are, and I can produce them all day long. And he said, how did you see these? And I said, with cell phones, we were able to see them. And he said, don't ever contact us again. And they use exactly the same technology to see their particles too. And he refuses to engage. So I feel a little bit hostile, but I'm going to be polite as I can be. Okay, just so you don't miss a thing, this is the red laser pulsing forward. Boom, boom, boom. Now, this little beam coming straight out of here is the particle literally accelerating. A venturi forces things to accelerate. However, here's what happened is accelerates, but then its magnetic field, which was recreating this wave, starts to get sucked forward. Now, what happens here is its magnetic field starts bumping the reverse concussing magnetic fields. Boom, 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 boom. So it starts slowing down. And that's what they see. They say the neutrino goes just below the speed of light, which is, we were at the speed of light. We increased it to faster than the speed of light, and now we slowed it down probably below the speed of light. And here, the particles no longer could stay attached and separated, as you can see. So what's happening here is the black and the white particles, which I showed you before, attached together as the muon and electron neutrinos hit the venturi, which is nothing more than two pins. There's literally two pins sticking down like that. You can't see them because it's such an enormous explosion, but they're right there. In that picture, here's what they are. There's a pin here and a pin right here. And they're so close to each other that the black can't get through. You see? It's hard for you to see, but I'm saying this is the size of the pins. The black can't get through. So it smashes, bam, 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 and squirts that white through with a vengeance. Then the black comes back to the white to create back to the normal particle, which is this particle here, the muon and electron neutrino as a part together. But we did create the sterile muon, which we broke it apart here, and we have, these are all sterile muons, the black ones. Same over here. And then we created the electron showers from the electron neutrino. So the muon neutrino just turned into the muon. Stayed the same as it was. Electron neutrino went into shower mode. All right. Now, what did they here? Let me just wipe that off So we can go and look at something else here. All right, you see that? You can't even see the Venturi for the explosion of radiance. But that's where it was. So what happened between here and the Venturi? The tau neutrino showed up first. Then the photons. And then the muon and electron neutrinos. Here it comes. Remember I said the tau is a black, a white, and a black? That makes it heavier than the white and the black, which is the muon, which is the black one, and the electron neutrino is the white one. This is a photon. So here's the light coming in. It starts to show up as this type of a neutrino, the tau neutrino, as it starts to concuss. Otherwise, this is light up here. You don't see it at all. Then all of a sudden you start to see it. This is when it's directly in line with the Venturi. That's when you get the photons show up really well, and all the particles. So tau, photon, which is 2 and 2. This is 2 and 1, 2 and 2. And then one on its own and the other one on its own here. So that's all your neutrinos and your photon all in one shot. And this is an identical situation. The black, white, black, and then all of a sudden the photon. And then when it hit, it splits. I can show you the split too. Only green is a little harder to control. Okay, this side here is 100% white. No black whatsoever. This side is where the black is going. So that's the separation right here. But the green, like I say, it's very powerful, so it's hard to control. Let me show you something. But as you can see, you see all the different concussion waves and the brilliance of that. And all the black is gone. There's not one single black here at all. Just like the red was, only this, we can't funnel it quite the same, but this is just sort of eyeballing it. We're not really doing any really sophisticated work here. This is very simple stuff to do, to be perfectly honest. See how much more powerful the green is? This is coming through the same slit at the same time, red and green. You see the green is just enormously powerful and reconcusses out here, just pushes the red out of the way. Now, this shows the same particles, and you can see a little redness in among the green, which is mixed particles. Each one of them's a particle on its own. That's all I can tell you. See, look at that. These are the greens coming through like crazy. All right, this is a blow-up of that other one I showed you, both of them coming through at the same time. Now, notice the brilliance. And he's showing that some of the red somehow got tangled up in here. Now, and then it reconcusses out here the green. But watch what happens here. And this never ever happens, except, this is the only time I've ever seen it happen. They're barrel rolling. You see this? That's not ever supposed to happen. They're supposed to go this way, with their axis towards the Earth. This is a barrel roll. And the green is doing it too. They're both doing it, the green and the red. You see, look. See a barrel rolling? That's not supposed to happen. Or let me put it this way, I've never seen it happen any other time. Alright, I showed you we can focus this whiteness through the Venturi, and look at what it does here. Well, what is this all about? Why are we getting all this? You see all these little white splatters coming all over it, like little paint splatters, swoosh. And all of these coming out of there. What is this? Well, let's take a closer look at it, because this right here is when the white joins back together with the black, and they form these, which they call Higgs fields. You see these spinning things they see at CERN, but this is just because it's debris. They're digging through this. We're down at the smallest little particles that exist, the tiniest of the tiniest. But it's the same similar patterns, these are circular disks. Okay, my model says these are the only two particles that exist. One of them has the energy, I'm going to call it the W is the white one, the Z is the black one. The two of them together make a gluon, which we've always called that an electron, which is a bar magnet. Electron is a positive and a negative, a white and a black. You take two of those together, you have a photon. That's it. The next time you have to worry about particles is when you get to the first stable quantity, which is a hydrogen core, which is about 1835. And that's not really very, very stable. You throw a spark into hydrogen and it explodes like a bomb. It's just unbelievably explosive. So it's not real stable. They get more and more stable as they get bigger and bigger and more solid. But the gas at that hydrogen level is quite explosive. Now, so I say that's the only two that exist. That's the only two. Now, the Higgs does not form these. These two, when they come back together, they form the Higgs. When they are separated, no Higgs. When they come back together, Higgs. Let me show you coming back together. So I can show you everything. I showed you as they formed into the tau neutrinos and then into the photons, and then they separated into the black and white particles. These are the Higgs fields. As they start to reconcuss, the white adds back to the black, which is disassociated here. This was fission, this is fusion. Here's the fusion right here. The white ones are coming forward, these fields. The tip of the field concusses first, and it reattaches to the black. The very tip, you see it? That's where the black is reincorporating to the white. Back here, they're still white. They haven't picked up on the black yet. Every now and then you see one or two here that started to pick up on the black, but primarily it's the tip. That's what this is right here. This is coming out of the venturi towards us, and that's where it was separated, turned white, and right there, right exactly there is what we're looking at and seeing all these reconcussions and that changing back from just being pure white to now going back to the black. So I've shown you every single phase of every single bit of it. I think that is worthy of a look by, somebody in the physics world, and I have yet to have any even questions. I was told not to contact Fermilab anymore because I became very, I started getting a little pushy because, why shouldn't I see, this is exactly, I'm going to show you what they say about neutrinos, because I just showed you the neutrinos. So let's get into what they say about it. I'm never going to walk away from this because I'm right about this. This is light. This is what they wish they could do, only they're using head-on collisions of protons and having just debris. They're picking through debris like it's trash. We're squirting them out and looking at them right in the face. All right, don't forget, I showed these to you in every phase. These two together as the neutrinos, these two apart as the sterile muon and the electron shower right there, and then two blacks and a white in the middle as the tau neutrino, and then two on each side as the photon. I showed you every assemblage that you can, well, I'm sure there's maybe something else, but if these are truly the smallest particles, and that's what they say, and I will probably have to agree with them, because this is coming from light. We're at light. They're hitting things head on, but they've been digging around here for 20 years or more probably to try to find the smallest particles they can find, and they are there, they are. That's exactly what they are, and they're exactly what we found. Identical, no difference whatsoever. I mean, as identical can possibly get. I mean, there is no more identical than that to these. And then we split them, creating fission and fusion. I would think that Fermilab might have a question about this, any discussion whatsoever. Not a single word from them. And they told me to stay away. That's not right. They're spending our money to do this, and I'm showing them how to do it. And I think I should be heard from. I should have some voice in this and not stay away. They have scientists. Have some scientists confront me about it. Not just say, no, we're not going to talk to you. That is not right. Okay, this is a boycott by Fermilab of Roger is just not right. They won't let me speak. They told me to stay away, leave it to the professionals. We know what we're doing. I'm showing them the particles they're looking for, and I'm using light. These are the particles right here, that it is. Now, if we could do this correctly, I think we could harvest free energy within weeks. But somebody's got to talk to me. I'm going to leave that the last word. I don't want to get, nasty or anything, and I don't want to be, step in anybody's territory, but this was just an accident. I don't care about any money, and Rod doesn't either. Rod Warren was the one that came up with this by accident. I was the one that saw it, and I said, Rod, you have no clue what you did, man. And then we worked together for years on this. And it is what it is. I'm showing exactly the particles they're looking for, created from light, which they had a special meeting in 1978 at a conference. How can we do particle collisions using light instead of protons? Because the protons are just too big, too much trash. And they never could figure out, and they dropped it. All right, look at this. This goes back a long time. LHC as a photon collider. That's what we're colliding, is photons. Now, listen to this. What they're using is 100 billion particles at a time when bunches cross each other, and they're smashing things to bits and just digging through the debris. 100 billion at a time. And they're only getting 25 or so to hit. But that's still 25 times 2,000. That's still hundreds of thousands of particles just splashed everywhere. So we're using light. So we're not using 100 billion particles. We're using 2 or 4. Now, what is it? Physics case for studying photon collisions like we're doing. Listen to this. The physics of photon collision has been a topic of some interest for many decades. Still is. Indeed, a special meeting in 1978 discussed the proposition of such collisions. 1978. And then they just dropped it. It said it was, here is it right here. It was first proposed to do this type of physics at LHC with CERN many years ago, but the project didn't materialize. They just couldn't figure out how to do it. We got to figure it out. I'm showing how to do it. And this is basically what you do, is you collide the particles together. Only they're using protons, we're using light. They thinking that some God particle creates these other particles out of nothing. I'm serious. Feynman, this is a Feynman diagram. Well, I'm going to show you something. I've shown it over and over, but Yale agrees. Feynman doesn't understand particle physics, and Feynman admits it, and so does Yale.